afternoon, all of you. I hope all are doing good. Today I am going to take a lecture on synchronous generator, which is also called as alternator. Alternator means alternating quantity, means sinusoidal quantity, or you call it as a AC quantity. Synchronous generator. What is synchronous? Synchronous generator is basically a AC generator which converts mechanical energy into electrical energy, or you can say mechanical energy into a AC quantity, right? Where it is used, synchronous generator? Synchronous generators are used in large size power stations like Koradi, Khaparkeda, Chandrapur. All over world we are using synchronous generator. Synchronous generator is very big in size, large in size. You can call it as a say 100 megawatt, 200 megawatt, 500 megawatt, even in the range of gigawatt also, right? So today I will cover the basic aspects of synchronous generator. First is, what is synchronous generator or how is its construction? Let us see. It consists of two parts. First part is stator. Stator. This is called as a stator, or we call it as a stationary part of the synchronous generator is called as stator, which is the outermost body of the machine is called as stator. It consists of many slots where three-phase winding is mounted. Windings are sandwiched in these stator slots. You can say this is your windings. Windings are present in these slots. Synchronous generator is a three-phase generator. It consists of three wires: R phase, Y phase, P phase, and the windings are mounted in this slot. And the second part of the synchronous machine is rotor. This is called as rotor. Rotor are of two types. One is salient pole type and other one is cylindrical type. Right? So there are two types of rotors, two types of synchronous machine. One is salient pole type and one is cylindrical. So cylindrical shape rotor is like this. Salient pole type rotor is like this, in which poles are projected outwards. You can see we call it as a dumbbell shape. Dumbbell shape rotor, we can call it as a dumbbell shape rotor. In this, poles are projected. In general, we are giving a DC supply. In general, we are giving a DC supply to the rotor. As soon as you give a DC supply, North Pole and South Pole. North Pole and South Pole is formed on the rotor. The rotor is generally mounted here in the center of the stator. And one thing is clear, you have to give a DC supply to the rotor. Corresponding North Pole and South Pole is produced. Now come to know what is the principle of operation of synchronous generator, how this synchronous generator works. What is the principle of operation of synchronous generator? This is a common question asked in the interview. What is synchronous generator? How it's work? So the synchronous, as everybody knows, generator principle. What generator does? Generator converts mechanical power input to electrical power input. So for our first step is to give a mechanical energy input to this motor. So mechanical energy input is given by the prime mover. Suppose this is a prime mover, any motor, any steam turbine, hydro turbine, or windmill, or say some any other motor or diesel engine motor. Like in our college, we are using a diesel motor. The motor runs with a diesel which provides prime mover to this synchronous generator, and this is coupled with this rotor. This is coupled with this rotor, so that rotor is rotated at synchronous speed. Rotor is rotated at synchronous speed. What do you mean by synchronous speed? This we will discuss. What is the synchronous speed? Synchronous speed is a constant speed with which generator is. Now try to understand the principle of operation of this synchronous generator. When you give a DC supply to the rotor, corresponding north pole and south poles are produced. As soon as north pole and south pole are produced, now what you are doing, you are giving a mechanical power input to this rotor and rotate this rotor at synchronous speed. Say the speed of this rotor is 3000 rpm. Suppose the speed of this rotor is 3000 rpm. So we have to rotate this rotor at 3000 rpm through prime mover. Prime mover may be anything. You have to rotate this rotor at 3000 rpm. As the rotor rotates at 3000 rpm, when this rotor is rotating at 3000 rpm, this north pole and south pole, is also rotating at 3000 rpm. You can say rotating magnetic field is produced. North pole and south pole is rotating continuously at synchronous speed. Rotating magnetic field is produced. The magnetic field is also rotating at synchronous speed. Rotor is also rotating at synchronous speed. This formula is given by Ns is equal to 120 F by E. This is the standard formula for synchronous speed. A rotating magnetic field is produced which rotates at synchronous speed. If you want a frequency of the supply as a 50 Hz, so if you put 50 Hz here and number of poles 3, then you will get a speed as a 3000 rpm. For 2-pole machine it is 3000 rpm. For 4-pole machine it is 1500 rpm. For 6-pole machine it is 1000 rpm. For 8-pole machine it is 750 rpm. Like this the rpm get reducing as number of pole increases. Now come to principal operation. What we are doing? We are giving DC supply to the rotor. Corresponding north pole and south pole are produced. When north pole and south poles are rotated at a speed of synchronous speed by prime mover, the rotating magnetic field is produced which rotates at synchronous speed. Now come to basic principle of operation of generator, Faraday's law. What Faraday's law says? Faraday's law says whenever there is a change in flux, EMF is induced. Whenever there is rate of change of flux, EMF is induced. That is E is equal to d phi by dt. E is equal to d phi by dt. You can say E is equal to minus n d phi by dt. Now let us see how this equation controls how this EMF is induced in this way. So as the rotor is rotating at synchronous speed, rotor is continuously rotated at synchronous speed, say 3000 rpm. This magnetic field is also rotating at synchronous speed. This magnetic field continuously cuts the flux. This magnetic field cuts the stator conductors. Or you can say this rotating magnetic field or this rotating flux is cutting these conductors, stator conductors continuously cutting. This means there is a rate of change of flux. There is a continuous rate of change of flux in this rotor conductors. Continuously rate of change of flux in this stator conductors. These conductors outside periphery of the stator in windings in the slot. There is a continuously rate of change of flux. Therefore, EMF is induced. EMF is induced in these rotor conductors. EMF is induced in these conductors and their voltage is available. VR, Vy and Vp is available at the end of the winding. This is how you can see that this synchronous generator converts mechanical power input to a electrical power output. When you give a mechanical power input, this rotor is rotating at synchronous speed which is cutting. DC supply is given to the rotor, therefore corresponding north pole and south poles are produced. These corresponding north pole and south poles are rotating at synchronous speed. You can say for field winding, north poles and south pole flux is also rotating at synchronous speed. And this rotating magnetic field is continuously cutting the flux. This rotating magnetic field is continuously cutting the conductors present in these slots. Continuously cutting the conductors present in those. Therefore, there is a rate of change of flux. In these stator conductors. Therefore, according to Faraday's law of electromagnetic induction, whenever there is a change in flux, whenever there is rate of change of flux, EMF is induced. Therefore, EMF is induced in this stator winding, and you will get an induced EMF as VR, Vy, and Vb. VV, and this is how the motor, this is how the generator converts mechanical power input into electrical power output. If you draw the table of this speed versus number of poles, this is speed and number of poles, and this is speed ms. For 2-pole machine it is 3000 rpm, for 4-pole machine it is 1500 rpm, for 6-pole machine it is 1000 rpm, for 8-pole machine it is 750 rpm. In this way we can have to set a frequency constant as 50 Hz. In the next lecture we will discuss the EMF induced. EMF equation, how much EMF is induced,